Hello, I'm Isaac Wenger, and this is Lab 4, Oscillations. The goal of this lab is to observe the oscillating motion of a mass attached to a spring and create a model matching the observed oscillations. The result was they predicted an observed motion matches up in both the x and y axis, and the total energy is 0 joules or close enough to 0 joules. The physics principles used is the energy principle, which states that the change in energy of a system is affected by the work done and the heat exchanged with the surroundings. And then the momentum principle, which states that the net force is equal to the change in momentum over the change in time. Here are some formulas. So energy principle, and then kinetic energy is just going to be 1/2 mass times velocity squared. Gravitational potential is going to be mass times gravity times the height. And then spring potential is similar to kinetic energy. It just uses spring stiffness instead of mass, and then the spring's stretched or compressed state instead of velocity. Then the velocity update formula, which is derived from Newton's second law, and position update formula. Here is the observed motion. Here is the initial conditions. So the mass of the mass is 0.402. The ball position found in the tracker is -0.11 for the x and -0.63 for the y. Ball velocity is going to be 0. Gravity is 9.8. Spring stiffness is found to be 6.83, and then L naught, or the relaxed length of the spring, is 0.123. To find L, you take the ball position minus spring position, then find L hat, which is L divided by the magnitude of L, and then S is magnitude of L minus L naught. Kinetic energy, gravitational potential, and spring are all the same as the formulas I showed. And then the only thing that's here that's different is energy is going to be kinetic energy plus gravitational potential plus spring, and that should equal 0 at the end. Gravity is just going to be -mg in the y direction. Spring is going to be negative spring stiffness times S times L hat. The net force is gravity plus the spring forces. Newton's second law will be ball velocity plus net force over mass times change in time. The position will be ball position plus the velocity times change in time. This has not changed, and this has not changed. The only thing is finding delta K, delta UG, and delta US. And that should be, the energy should be 0, and then change in energy should also be 0. Here is the modeled motion. So some possible errors is that I had to manually track the mass by hand, which could have resulted in possible errors, and this does not account for drag force as the mass oscillates in the air. What does this mean? The energy principle is satisfied because the potential spring force and the gravitational potential force are opposites. So they almost cancel each other out, and added with kinetic energy, it does cancel each other out, and as you can see, the energy is 0 or close enough to 0 that it doesn't really matter. The period of oscillation for the x direction was found by taking the first position where it's at the bottom, and the second, and that was found to be 1.614 seconds. Period of oscillation for the y is taking here, this position, and this position, and subtracting the time, and that was found to be 1.519 seconds. The period of oscillation is slightly different between the x and y axis. That could just be because of me not tracking the motion correctly in Tracker.